That's the most important thing, right? So please look at the screen. Don't do anything. Watch everything carefully. Whatever you want to do or write, you write down while I say. I will start my Hadoop and all the scripts by a script. So just like how you are doing start all.sh in Mac, we are now starting this particular Hadoop environment. Make sure, as mentioned in the previous classes and as you are completely aware, you have got name node, data node, secondary name node, and then you have got the resource manager, and then you have got the H catalog, and then you have got the node manager. So make sure that all that processes are running, and do a JPS. I told you in Cloudera you will do a PS minus FU, which is telling you what is the process that are running. For example, PS minus FU yarn. It will tell you whether yarn is running or not. In Mac, you will do a JPS, and it should show you mainly the data node, the name node, the node manager, and the resource manager. So all are okay. Now I am going to go to my code directory, which is there in my directory as Hadoop code. In your system, in your Cloudera, you will have it in MapReduce folder. There are so much code there. We will see one by one. These are all what we are going to do in the coming days. What I am going to do, first thing is that, and this is what you will also be doing whenever you get a job and you are writing the MapReduce program, you will have that concept1 directory. So I am creating a copy of that concept1 directory. How will I do that? CP copy minus R, which means recursively take all the things. Concepts1 is the directory name, and I want to create it into a folder called my demo. Okay, if you don't write minus R, only the directory will be copied. Nothing inside will be copied. I want everything. Okay, and remember, when you do this, what will happen is that build.xml, which is referring to your master lib in the last class, that is also getting copied. Okay, so you don't have to do anything. In my computer, there is no master lib. For you, everything is created in the last class. So once you copy this particular thing, why it is taking time is that in my code that entire lib is also getting copied. And now you have got cd my demo, right? And if you look at ls, everything is available inside this particular thing. And what I am going to do, I don't want anything unnecessary here. rm minus rf, I am going to delete all that is not needed. For example, I don't that abc.txt, I don't need attic, I don't need test, I don't need temp, I don't need this one dist, all these things I am deleting. And I think there is a unnecessary copy created called concepts1, that also I don't need. So rm minus rf, that concept1 is already there, and then I don't need rm minus rf classes. GPO access, which is a file, I don't want that one. Yes, but I need three things basically, and you need only two things. And apply your learnings that you did in the last class. Why you need only two things? Because master lib is outside for you. For me, it is lib. To give you a clear description, in my build.xml, I am referring to my lib directory. Look at that line. But in your build.xml, you are referring to master lib directory. That is why you won't see lib directory, but I will see the lib directory. Now I am going to src. src is the place where the code is there. And as I mentioned to you in the last class, always it is good to work with the two terminals. So I am opening one more terminal. I am keeping it on the right hand side. This terminal I am going to use for compiling my code. This terminal I will use for changing my code wherever reader. So I am going to go to the same directory, Hadoop code, okay, and then I am going to go to directory called my demo. Look at that. My demo is the directory that I created. Everything your command prompt tells. Don't tell that I didn't find my hadoop.jar or something like that. Look where you are always. And if at any cost you are getting a doubt, just type pwd, it will tell you where you are. Okay, if you type cd, you will go back to your home directory. If you type bwd now, it is the home directory. Again, you will come to Hadoop code by typing Hadoop code and then going to my demo, right? It is just like traversing between directories. So you created my demo, and this particular screen on the right hand side is only for compilation. and this particular screen on the left hand side is for writing the code. So I am going to com directory, and as you know, inside the com you will see Ravi, and if you want to change it, you can move Ravi to your own folder name, whatever this is, but if you move to another folder, make sure your program is also getting changed. So I have got a code called sum.java. Okay, so what I am going to do, rm minus rf gpo access.txt, I am deleting this particular file, and I am going to take this sum.java. Okay, the most important thing is that in the last class, whenever we write the code, at the time you might have seen that this was not interwritable. Okay, it was interwritable, and every time whenever you were writing a number, you wrote the number 1 for your MapReduce programs. Okay, for example, when you had hello world twinkle like this, in your map logic you wrote this word hello and then you wrote 1. This world comma 1, and if there is one more hello coming in, you will write again hello comma 1. Remember about the pineapples, limes and the mangoes. Mango comma 1, lime comma 1, pineapple comma 1. You wrote all these things. And then the MapReduce having a beautiful facility that the same keys will be pushed into the same reducer. That's why that hello will go to the same reducer and will add that result 1 plus 1 as 2, and you get the word count result. Now I asked you, your numbers are going to be 10, 30, 40 like that. What I am going to do, this is where the logic and the beauty of programming is coming in. Inside the map, I am taking this. If I take the line number, as some of you told, line numbers are different. It will go to different reducers. I want the same key. So I will hard code a key called result. That's it. And then I will read the numbers. Result comma 10, result comma 20, result comma 30, result comma 40. So I made the key same. That's the trick there. And when you make the key same, the reducer is going to get all the keys result into one person. And that result, now you sum it. 10 plus 20 plus 30, 40, you got the result. That's all. So very simple program. So if suppose you are looking at the code, you can see that I made a change. Okay, what did I do? I wrote result as my key, and whatever number I am getting, this particular place you wrote the number 1 in your MapReduce program, because every word 1, 1, 1. Now you cannot write result comma 1. You should write result comma 10, that number which is coming in. Result comma 20, result comma 30, result comma 40. That's what you are doing it. And if you look at your word count program, you will see you are not writing this number here. Instead, you are writing the word 1 here. And I will show you by opening another terminal. So go to next one. The next one, and then I go to, let's say, another window which is a blue colored window, and then I go to the Hadoop code, and then I go to, let us say, another folder, the old program, and then I go to VI, source will contain my code, com will contain my code, Ravi will be the folder, and the name of the code is wordcount.java. And if you look at the wordcount.java, look at that, the first line, new int writable 1, and then you wrote the key and value, which is the 1 which you declared on the top, right? 1 is the value that you declared as number 1 on the top, and the data type is int writable. Int writable means it is a kind of integer that you are writing. So hello comma 1, world comma 1, next word comma 1, like that it will be printed. But if I close this particular terminal now and you come back to this particular program, look at the change. I am not writing 1 there. I am writing what I read, which is S, which is a string, right? And you look at that, string is tokenizer.next token. So if you are familiar with Java, what is a tokenizer? Okay, you should know what is a tokenizer. A tokenizer has got the ability to get the tokens. For example, if I write a line that quick brown fox as one line, and if I call this particular thing given to something called a string tokenizer, what string tokenizer will do is, it will take this string and will give you the tokens. What is a token? Quick is a token, brown is a token, fox is a token. So you got the tokens, and you take that token and emit that token, comma 1, brown, comma 1, fox, comma 1. In this case, my token is nothing but the string number. That string is a Java string. String is different from a number. Why it is different from a number? A string always represented in Java in double quote, but a number, you cannot convert hello to a number, not possible. But this, when read as a string 10, I can convert it into a number, which is number 10. So I have to convert it into a number. Why? Why I should convert? Again, apply complete concentration on what did you write in your map. Your map says that the key is of type text, the last two parameters, and the value is of type int. If you say that your value is of type int, and if you give a string, it will give you an error. The compiler will tell you when you run the program that int writable is coming in, string writable is expected, but you use int writable. Like that, you will get an error. That's why I told you, always read the messages. It will give you the clear cut message. So I changed that also. And inside that int writable, you are writing that particular number now, and the result is there. And now your reducer, no change at all. Look at that, just exactly like a word count program. So hello 2 times. Now in this case, result, but you are going to add all these numbers. Instead of adding 1, 1, 1, 1 in your code, now you are adding the numbers. Now, let us run this particular code, and then I'm going to run this particular program, and let me comment out some lines just for illustrating some other features. I'll comment this line, I'll comment this line, and I will comment this line. Okay, in Java, if you write this // that means that line will not be considered as part of the program. It is called a comment. And what I will do, I will come to this code, and then as I told you, this is the screen for compiling my code. And make sure that whenever you write and, that build.xml is there in the directory, and then and clean. If you are not sure whether you cleaned the directory or not, it will create all the directory for you, and you can see that now whatever directories I deleted, everything got created. And now you type and one more time, it will compile the code, and you should get build successful. Okay, if you don't get a build failed, then you should look at the message, error message. In plain English, it will tell you what is the problem. And now you compile the code, and then I am going to go to the dist folder, right? Before going to run the MapReduce program, I have to do the basic step. What is the basic step? I am going to write a file vi abc.txt, and abc.txt is containing a number 10 and a number 20 and a number 30 and a number 40. And I am expecting the result to be 100 as the result, because 40 plus 30 plus 20 plus 10 is 100. And now I am coming out, abc.txt is in my local file system. I am creating a directory, hadoop fs minus mkdir / in Mac and no / in Cloudera. I am going to create February 11 as the make directory, and I created a directory. Make directory is February 11. And now what I am going to do is I am going to put this file, and the command is hadoop fs minus put, and the name of the file that you created is abc.txt, and I am going to put it into February 11 folder. Once all the things are there and you are in the dist directory, make sure my hadoop.jar is in that directory, right? And you created abc.txt. Now you don't need abc.txt anymore. Why? Because you already put it into the file system. If you want, I can delete it. abc.txt, I can delete it, right? And make sure that your my hadoop.jar is there, and now it is a matter of writing the code. Hadoop jar my hadoop.jar. My program is com.ravi. Not word count. If you have explored my code earlier, it was sum.java. Look at ls. It is sum.java, and don't write word count. Word count, if you write, if you put a space, anything you make wrong in the program name, it will tell you file not found, some class not found. And the input is February 11, and the output is February 11 O, which is just an output folder, and press enter. If everything is okay, you will be getting the MapReduce kick started with a job ID and an application ID, right? This is the application ID. Okay, every MapReduce program will have an application ID and a job ID. So we are going to the details now. We will go to more details at a later point of time. And always, first the map will be executed, reduce will be executed. If you get this kind of things, and if you look at the number of input records and all those things, you can get a feel. 4 lines were there in my code. That's why it is telling you all the details. And now if I do hadoop fs minus cat, and what will be the output folder name? February 11 O is the output that I created. And as you know, path-r-1 2 3 4 5 will give me the output that you need. And if everything is okay, you should get a result as 100. That means now you combined all these things. And let us do some more things here. I'm going to create another file called pqr.txt, and inside the pqr.txt again I am going to type 10, 20 and then 30 and 40 again. Okay, so I am coming out, and now I am going to do what I am going to do. I am going to take my previous command which I have executed, hadoop fs minus putting, instead of abc.txt I am putting one more file pqr.txt also. So remember, now my input folder is containing two files, abc.txt and pqr.txt, and you can check it by typing hadoop fs minus ls slash February 11, and you should see two files now instead of one file, which is abc.txt and pqr.txt. And now let us write the program. I don't need pqr.txt from the local file system. I can remove it. So in my ls now hadoop.jar is there. And let me remove the output directory just now I created. Why? Because in Hadoop you cannot overwrite the directory, output directory. Every time you have to give a new name. I don't want to clutter it. So hadoop fs minus rmr slash February 11 oh sorry, it is not 0. February 11 is the output directory that I have. So I am deleting that particular one. Clear? And now I am going to do the MapReduce program again by running the same code. Look, I am not typing at all. Unix, the previous commands, everything is available in the key. And then press enter. When you press enter, now it is going to run the MapReduce program. Only thing is that now your input directory is containing multiple files. So there is abc.txt, same numbers 10, 20, 30, 40, and there is pqr.txt. You have seen two files with the same data. And what we are going to do after executing the MapReduce program, I am going to go to again the same command to look at what's the result now I am getting in part-r-000. And if you look at the output now, you will see result equal to 200, which means that if multiple files are there in that particular directory, your MapReduce program, without writing anything in the code, automatically will recurse through all the input files and will apply that same logic onto that particular one. This is how in professional environment Hadoop is used. When the ETL programs and everything is getting executed, one directory will be designated as the directory for that particular organization. At the end of the night, all the files will be going to that particular directory, and your MapReduce program will be only one which is pointing to that directory, and recursively it is going to take it. Now, very important thing, result 200. Why? What the heck is this space? I don't want that space. MapReduce by default will always create tab. Tab is the white space as the default separator whenever you are creating. I want a comma separated value file. I don't want that particular one. You can do that. Okay, a little bit tricky part. Okay, the way in which you are going to do it is that you have to set something onto your configuration. What is meant by configuration? When you write a MapReduce program, by default, it will take all the properties that you have mentioned in your property files. What are the property files? MapReduce site.xml, yarn site.xml, core site.xml. All these property files will be taken into an object called configuration. If you look inside your program via isam.java, you will see a place in the main program. The first line of the MapReduce program is always going to be get the configuration. Configuration conf equal to new configuration. That configuration object contains each and everything. By default, the separator text for MapReduce output is space or tab. I am going to change it. You have to write 3 lines, and you may ask why 3 lines? Problem in MapReduce. The problem is some people might be using one version of Hadoop, some people will be using another version of Hadoop. I want your code to work in every environment. So write 3 times this particular line. All the 3 are slightly different in the syntax. One is telling that MapReduce text output separator text. One is telling MapReduce.output.separator. One is telling MapReduce.output.key.field.separator. All the 3 you write irrespective of whichever Hadoop environment you are using, and then let us execute this particular program. So if I do this and then I am executing this program, for example, I am saving this program, I saved it, and I told you this terminal is for compilation. So I am going to the parent directory. Don't compile it in the dist folder. You are in the dist folder. Look at that, where you are always when you type a command. Look where you are. You are in the dist, as you can see here. You cannot compile. Why? Because your build.xml is not there. So I am going to the parent directory, and now I have the build.xml in this directory. I can now write ant. And what is a guarantee that your ant is taking the new file that you saved? You will see the message. compiling. Okay, look at that. And see, it is telling compiling one source file because Ant is very intelligent that you changed the file. It knows the timestamp when you changed it. Now look, if I type and one more time, what will happen? If I type and one more time, I didn't make any change in my code. It will not compile at all. It will directly tell you it is not compiling. So that's the trick to know whether your code is compiled or not. So now your code is compiled. So cd dist will contain the code, right? And I am going to do one more thing. I am using, now I don't have to type any command. Why? Because everything is there in my buffer. So I am just navigating it. And I am deleting this directory called feb11 output, which I have already created. And after creating this particular output, I am going to run that particular program, not changing anything. I am just giving the same output inside this. I should not see result space 200 now. I should see result comma 200 because I changed the default parameter. So in a professional environment, if suppose you have a Cognos or a business object report which is able to read only CSV files, cannot read tab separated files, then your MapReduce program should create CSV, otherwise your report will fail. So you need to set this parameter in order to make sure that that particular value is created. So if I do an Hadoop fs minus cat now and you look at the part 000, you must get a result comma 200, which means that you change the separator for your program. And now what I am going to do is that I am going to go to the folder again, and then I am going to do the word count program. So where is my word count? So dd.ls, and I don't know where is my word count, and maybe inside concept 3. Concepts 3 or concepts 1, I don't think concept 1 is there. I will go to cd distribution, which is another folder that I am keeping. Okay, I have got the cd concepts 1 here, concept 1 here. Only thing is that I might not have a lib. Why? Because I created this folder for distribution purposes. So what I am going to do, without a lib directory, I cannot run my code. Without master lib, you cannot run the code. In the similar way, I cannot run the code without lib. There is no lib in this folder. What I am going to do, cp -r, copy that lib directory from the parent concepts 1 directory and then take that lib directory and then bring it, right? So how will you go to the parent? cd one level up and again one more level up, and then concepts 1/lib is the folder, and I am going to put a dot, which means that I am bringing all that lib directory inside this. Oh, I did a mistake because I think it's fine. Instead of doing that lib folder, I created all the files. See what a small problem in the command that it created. So what I will do, mkdir lib, and then I will go to lib directory, and unnecessarily I copied all the jar files. So from the parent, I am taking all the jar file and copy to here. This is not Hadoop, this is Unix. And now if you type this one, you will now see that it is created the lib directory, and everything is now very clear. So if I look at ls now, oh, I did cp. So now I can move or delete all the jar files, rm star.jar. Don't write rm -rf, everything will get deleted. And is it cleaned up now? ls, very good, it is cleaned up now. Now you created the lib directory. So it's a play of Unix commands. You see what I did? And I got a mistake, right? When I copied the file, all jar files came instead of the lib folder. I just created lib and I moved all the files inside this. Now I want to make sure that my program is correct. So which folder I am in? pwd will tell you I am in Hadoop code distribution concept 1. So I am going here. This is my window for writing the code. So cd clear, and then cd Hadoop code, right? And then cd distribution, and then cd concepts 1, right? This is the place where I am on the right hand side, right? I am at this particular place. Now what I want to do is that I want to check my code. How will I check my code? vi source com Ravi, and there must be word count.java, and I have got the word count. I am making sure that the word count is already available. Yes, beautiful. The word count is already available, and you already remember that in the previous code we changed the code to have the separator. Where is that code? It is available in the parent folder in another concept1 directory, and I want to open that, copy that, and put it into this word count.java. How will I do that? I am going to take the code from the parent directory. How will I go to the parent? One level up is distribution directory, another level up is the parent directory, and then I am going to take the concept 1, and inside the concept 1 there is a source, and there is com, and there is Ravi, and there is some.java. right? And you can just type like this and you can see whether it is available or not. Is there some.java? No. I think I have changed the folder name to not concepts1. Instead I called it as my demo or something. Yeah, my demo, and then com, and then my demo source, sorry, my demo source, and then com, see, Ravi, and then some.java. Yes, that is some.java. So I'm taking that file. Look, from this directory I'm traversing to the parent directory, and then I go here, and then I'm going to take that 3 lines. The 3 lines are available here, and I take this and press Ctrl C, which is copied into my buffer, came back, and now I am in which folder? In the word count folder in concept1. And I am going to go to my word count.java, and I am coming down, and wherever that configuration is there, I am going to this particular place. Shift dollar will take you to the end of the line, shift dollar, and then go to A and then press enter and command V. I copied all that files from that folder to this folder, right? So now the word count program should give me the result. The result is going to be the word count program, and I should be getting with the result by comma separated value file. So let's look at that, and I'm going to do an AND to make sure that everything is running. Of course, I don't do AND here. I will go here and then I will do the AND here. And if you want to delete all the previous code, you can do an AND, and you change the code. Look, you should get the message compiling. Okay, compiling 2 source files, and you can see it is now building the successful jar file, right? And now I want a bigger file in order to put it into my input folder. So let me create a new input folder. So Hadoop fs minus rmr, all the previous inputs I am deleting. February 11 star, February 11 input, February 11 output, everything will get deleted. So from the Hadoop file system, Hadoop fs minus rmr, or no, February, no, minus. So I deleted that completely, right? And February 11 O, right? February 11 O. That was the output directory name. Oh, sorry, I didn't put slash. See, that's what you should do. So February 11 star, I deleted both the files. Good. It deleted. You see, it is giving you the message very clearly, telling that both the files got deleted. February 11 is deleted and February 11 output is deleted. Now let us create a file, right? And the file we will put it as vi abc.txt again, and inside the abc.txt twinkle twinkle little, and then again next line little, and then the next line twinkle, and then again little, and then again star, and again star, and again twinkle. Just some random data, and then star, right? I created abc.txt, and after that abc.txt is created, Hadoop fs minus mkdir, right, slash February 11, because I deleted all the other directories earlier. And now Hadoop fs, you understand the need of Hadoop commands now? In every program you need it. Fs minus put abc.txt into slash February 11. Very good. So you go created this particular one, and you put that particular file, and now you are going to go to your dist folder. Don't forget to go to the dist folder, because that is where you will run your program. And then use your arrow keys, go to that previous command, whatever is available to you, and then go to that place where you are writing your code earlier, that sum.java. Yeah, com.ravi.sum, February 11 and February output. Now don't run that sum, because foolish, right? Now we don't have sum.java. What is the name of the program? Word count is the name of the program. And then run this particular code. Now it should execute the word count, and it should create the output into February 11 O as the output directory. Okay. So it's running a MapReduce program now, and it is using that comma separated because I put the code. And now you do Hadoop fs minus cat. Where is that? Where, just to go to the previous command, and then write Hadoop fs minus cat, this particular one, and then look at the output that you created. Okay. What is the output? Oh, I didn't put the February 11. Oh, I think there is something different in the code. Don't worry. I will explain you this later. I got this particular output now, and I got all the data. But don't worry, why it is not giving you the sum? Why? Because I made some changes. That is why I put part-m-000. Why? I will just change it, and I will run the main program so that you are not confused. So I go here, and I don't want this line. Yeah. and then I come here and then I compile it one more time. But before compiling, I am going to delete my Hadoop fs minus rmr slash February 11. Oh, the output directory I am deleting because you cannot overwrite it. And I go to the parent directory, and in this particular place I do the and. Why? Because build.xml is here. See, I changed the file, so it is compiling. Clear, and then cd dist, and then in the dist folder I will run the MapReduce program one more time. Hadoop jar my hadoop.jar. So when I run the MapReduce program now, it should take the word count, and I think you should get the output clearly, because earlier you are seeing a difference which we will see in the subsequent classes. Don't worry about that now. So now I should get the output very clearly, and it is creating the MapReduce now, and it should run. And then if I look at the Hadoop fs minus r instead of this one, I am doing R now. I should get the output clearly now. Yes, little 3 star 3 and twinkle 4 you got. And now I am going to copy this particular file into my home directory. Where is my home directory? CD. But I have to check whether there is abc.txt. First I will delete rm minus rf. Is there an abc? Tilde means I am taking my home directory. I am deleting this abc.txt. And now I am going to copy this particular file into local. How will you copy? Hadoop fs minus copy to local. Which file? This file from this part r.000, right? Oh, sorry. Clear? Yeah. Then Hadoop fs minus copy to local from where? Slash February 11 output slash part dash r dash 1 2 3 4 5 2 dot. That's copy to local command. And if you press enter, it should run ls part.rs. I am now going to move this file name as move part as abc.txt. I renamed it abc.txt, and I am going to take this cp abc.txt into my home folder, and I am going to check it whether it is created abc.txt in the home folder or not. Yes, it is created. Now you brought the result from the Hadoop environment, back it. And now what I am going to do is I am going to run a little bit of magic here. The end of MapReduce means the real use of MapReduce program. What I am going to do, I am going to go to the parent directory, and I am going to run a beautiful tool which you are going to install today if we are. Okay? And or a better alternative for SAS, which is used for machine learning. And you've got a beautiful tool called R Studio, in which you can write R code. This is not part of the course. I am not teaching. R code allows you to write very advanced machine learning algorithms onto the top. And what I am going to do is, I am going to write some code here. Yesterday I just created the command for that. And I am going to write a library in the R Studio, and as you can see, after typing it, I will show you abc.txt I am reading, and I want to create a pie chart. And please look, in abc.txt the separator is comma. From where that comma came? In my code I already changed that default separator from space to comma, and I am creating columns called word and frequency, and then I want to create a chart called my first Hadoop chart by using that particular code. So abc.txt is already there, and I am writing that particular code, and you will see the percentage of how many twinkle, delete, and star came. That is the end-to-end of MapReduce. That is how Hadoop is being used in the world. Oh, it is not good. Where you are going to have the code, and then you run the graph and you analyze it. And if suppose you are going to do this particular publish button, and I am going to publish into a website called rpubs, and then click on publish. It is telling that it is uploading the port, and you can see and you can log in it. And let me try logging into this site. You have to create an account and then do the signing. And I am creating a graph called Passion Bytes. Okay, Passion Bytes is the name of this particular graph. Description, my first graph, right? My first graph. And it is there in this particular folder, and you can give it and then click on continue. And when you click on continue, you will see that the graph that you created from R has got now published to a global website. And you can now take that URL and send to this boss, send to your boss, telling that this is the MapReduce program, this is the output that I have created, and this is the analytics that I have created. Come on, let's do. So start your virtual this one, virtual box, and we will start by writing the word count. You already have the word count program. So what you need to do is that open your word count. So I'm stopping this video recording. So all this what I